Hi, my name is Numera Paul, and I work in operations for the Ontario Clean Water Agency. Welcome to our tour of a wastewater treatment facility. Today, we're going to see how wastewater from your home is processed, treated, and returned safely back to the environment. We're at the Kitchener Wastewater Treatment Facility. A lot of the processes that you will see today can be found in other municipalities across Ontario. Let's go! Once you flush your toilet, where does it go? Using gravity and water, it travels through the many kilometers of pipes in our city, and eventually, it makes its way here to the Headworks. All waste is directed into what is called partial flumes. These are used to calculate both the daily and immediate flow rates. All the raw sewage flows through perforated plate screens to remove large inorganic debris. This includes branches, leaves, wipes, and anything else that gets flushed into the system but can't break down. If we don't do this, we'd have a big mess. Your toilet can make a real mess when it's clogged. Now imagine this facility backing up. We make sure this system stays clear of debris to prevent breakdowns and costly tank cleanouts. From here, sewage flows to machines called vortex grit separators, where grit and heavy solids like gravel and asphalt are collected and then removed for landfilling. This is important because the grit is abrasive and can prematurely wear out our equipment. Wastewater then travels into primary clarifiers, which are large tanks that reduce flow speed, allowing gravity to settle most of the solids contained in the wastewater. In other words, this is where we take out most of the poop from the water. Exciting, huh? Typically, 50 to 75% of solids can be removed during this initial step. At this point, any fats, oils, and grease float to the surface of the water column. These fats, oils, and grease, nicknamed fog, mainly come from homes and businesses where they are poured down the drain after cooking. Remember to always collect your household fog and properly dispose of it in the green bin or garbage. Next, equipment is used to collect settled solids, or sludge, and accumulated fog, or scum. Sludge and scum are then pumped into the digestion process where they are broken down even further. The rest of the wastewater, or primary effluent, are sent into the aeration tanks for further treatment. Look at all that action! These tanks contain microorganisms that in the industry we call bugs, which help to break down the remaining biodegradable contaminants. Bugs feeding on organic matter bind solid particles in the water into larger masses called floc, which helps them to settle. This phase uses processes that nature typically takes care of. The difference is, optimal conditions are being created to help speed up the process. Next, air is diffused throughout the tanks. The addition of air does quite a bit. It mixes the contents, keeps the solids dispersed, and provides dissolved oxygen to support the bugs as they continue eating. This is called the breakdown. The sewage and biomass flows from the aeration tanks to the secondary clarifiers. These clarifiers allow the solids containing the bugs to settle at the bottom of the tanks while the clear liquid flows to the surface. Now, at this point, a portion of the settled sludge is sent back to the front of the aeration process to provide the necessary bugs to continue the treatment process. This is what we call return activated sludge. The other portion is removed and sent through the digestion process. This helps keep the bug population at an ideal level every step of the way. It is important to note that the blowers that feed the aeration process account for almost 50% of total plant energy costs. Careful monitoring of efficiency is a must. Let's move from our secondary clarifiers to our filters and tertiary treatment. This is where clean water is directed from these clarifiers to the filters. At this point, any small particles or solids that haven't yet been removed in the process will be filtered out. When these filters become dirty or fouled, a backwash is performed. This rinses all of the collected solids and pumps them back to the start of the process to go through the treatment plant all over again. Newly filtered water is then discharged and en route to the next process. The cleaned and freshly filtered water now flows through channels filled with banks of ultraviolet lamps. Here, any remaining pathogens are inactivated. After disinfection, the wastewater is fully treated. Now it can be discharged back to the environment, typically into a nearby water body. That's what happens to the water, but what about the sludge? From clarifiers, sludge is sent to atmospherically sealed tanks where it is mixed and heated to approximately 36 degrees Celsius, which is the ideal temperature for the bacteria to multiply within the tanks. This activity further breaks down the organic contents of the sludge. The primary byproduct of this decomposition process is, of course, methane gas. Methane is collected in a special roof or membrane within the tank and stored. As it is a greenhouse gas, it must be combusted prior to release. This means we have to burn it. It can be burned in a waste gas flare or used to fuel boilers for buildings or even for plant heating requirements. If it's used to fuel a cogeneration unit, it could be used to provide electricity right back to the plant. The sludge that has been fully anaerobically digested is then sent to dewatering, where mechanical equipment and chemicals help separate the solids from any remaining liquids. This process reduces the overall volume of the sludge and helps keep trucking disposal costs down. The remaining liquid sludge is converted into something called cake. It's like topsoil, but 100% not a dessert. The dewatered cake is then hauled off-site for use in fertilizing farm fields, tailing pond remediation, or in some cases, for landfill. Next time you contribute to this process, I hope you think of us and the important work that we do. We all take great pride in converting wastewater to clean water. We hope you enjoyed our tour.